we're going to add one more skill into our tool belt, our geometer's tool belt, on how to prove triangle congruence and even other things about triangles. And that is using coordinates to make certain discoveries about a triangle or another type of figure. So if we're using coordinates, basically what this is getting at is that we're going to use the distance formula. Everybody remember the distance formula? We'll go over it in just a second. We're using the distance formula to find numerical values of the side lengths as opposed to being given to you. Okay? And then proceed with the proof as usual. Okay? So let's recall. Parallel slopes are the same. Perpendicular slopes are negative reciprocals of each other. Okay? Also recall that the distance formula says that the square root, this big square root, of the difference in the x's squared plus the difference in the y's squared, that's the distance between 2 points, where x1 and y1 and x2, y2 are the endpoints of the distance you are trying to calculate. Okay? So let's look at a very basic example. And so let's say that we want to prove triangle ABC is congruent to triangle PQR. Okay, let's show that triangle ABC, which is down here, ABC is congruent to PQR. Okay, so all we're given is the coordinates of the endpoints. So let's look at the distance. So we're going to set up. Of course, if we have all of this, we could, I can calculate the distance here and show that it's the same as that one. I'm just going with the naming scheme, so AB would have to be congruent to PQ. I could show BC is congruent to QR, again going with the naming scheme right there. And I can show that the last one is also congruent to the last one, but I have to calculate the distances for all these, so let's just go through it. Going with the bottom triangle, okay? Let's just go with the top triangle because it's right here. So the distance between P and Q, okay, is going to be, okay, so we're looking at, if this is x2 and this is x1, we're looking at the difference in the x's. So I'm going to work backwards here. So well, you can do it either way because you're squaring everything, so it's not going to matter. So what I typically do is I go PQ. So that's 2 and that's 1, even though it seems backwards to do that because your 2's are going to be listed first. So if this is listed PQ, it just makes sense to go 2, 1. If this is PQ, PQ, 2, 1, 2, 1. So that's the way I usually do it. So looking at P, with the x's, we're going to have 4 minus 2 squared, and then we're going to add 5 minus 2 squared, and all of that. So 4 minus 2 is 2, quantity squared is 4, so all this is 4. 5 minus 2 is 3, squared is 9, so this is 4 plus 9 is 13, so this is the square root of 13. The distance of, what's our next one? QR is, okay, distance of QR. So going from QR, I've got the difference in the x's, so 2 minus 5 squared, and I've got the y's, 2 minus 1 squared. 2 minus 5 is negative 3, but squared is going to be a positive 9. And you can even just jot this down right here if you need to remember. So 4 minus 2, 2 squared is 4. 5 minus 2 is 3, squared is 9. Alright, so 2 minus 1 is 1, squared is 1. So 9 plus 1 is 10, so this will be the square root of 10. And then the distance of RP, again, I'm just taking the nomenclature and I'm just going from R back to P. So the distance of RP is going to be 5 minus 4 and 1 minus 5. So 5 minus 4 is 1, squared is 1. 1 minus 5 is negative 4, squared is 16. So 1 plus 16, this will be the square root of 17. And then if we show the same thing for these, we'll know that the side and the side are congruent, so we have SSS congruent. So let's go over here and we'll say D of AB. Okay, so the square root there, yeah, and I made that a little bit too short. Okay, so the distance of AB, I know this is getting cramped, but just stick with me. So A, it gives me a -3 minus a -5. Be careful with the negatives there. Squared. And the y is going to be -1 minus a -4 squared. That comes in there. And so that's going to be -3 plus 5 is going to be 2. And 2 squared is 4. And -1 plus 4 is +3 squared is 9. And notice that my 4's and my 9's already match up, so I know I'm going to get a square root of 13 out of this. And the distance of BC is BC, so -5 minus a -2 squared and a -4 minus a -5 squared. And again, I'm making my radicals too short, so -5 plus 2 is a -3 squared is going to give me a 9. So this is a 9. And -4 plus 5 is going to give me a 1. That's going to give me a 1. Again, I have a 9 and a 1, just like up there, so I've got a square root of 10. And if I did the exact same thing, I would see that distance of CA is the square root of 17. And so what this is showing me, notice what this is showing me. This is showing me that the distance of PQ matches up with the distance of AB. It's showing me that the distance of PR matches up with the distance of BC, and it's showing me that the distance of RP matches up with the distance of CA. And so I have side, and I have side, and I have side. So I have SSS, and so I do indeed fact know that those triangles are congruent. And so now we're going to do one more example where we are not showing that triangles are congruent, but rather that we are showing that it's a right triangle or that it's isosceles. And again, we're just using the distance formula and what we know about slope, the parallel slopes and perpendicular slopes, to make some determinations about the parts of the triangle. So let's suppose, I'm just getting this next piece of notes pulled up here. Let's suppose that I have this scenario. Okay, so let's suppose that I have, excuse me, I have these axes, and of course here's x and y. Okay. And let's suppose that I have my given is triangle ABC, where A is 4, -1, B is 5, 6, and C is 1, 3. So I'm given my vertices, and I need to prove that triangle ABC is right and isosceles. Okay, that it's a right and isosceles triangle. So right would mean a perpendicular angle, and isosceles meaning it has two sides the same. So let's plot this thing. Okay, so 4, -1 would be somewhere like here, and this is all this is doing is just helping me visualize this. Okay, B is 5, 6. B is going to be way up here, and C is 1, 3. So C is 1, 3. So I have something that, and I'm just sketching this. It just is going to help me see it. So A is 4, -1. B is 5, 6, and C is 1, 3. Okay, and like I said, this is just helping me visualize this. All right. Okay, so what we need to do, we need to find a couple of sides that are the same length, and we need to show that one of these angles is a right angle. Now, it looks like, of course, we can't always go by what the diagram looks like, but it looks like that might be our candidate for a right angle. So we might want to show that these two are congruent, or rather are perpendicular. And it also looks like maybe, just maybe, that that side and that side are congruent, so it might be worth our while to show that those sides are congruent. So let's start out with that. So let's say that the distance of AC, okay, the distance of AC is, okay, so AC, I'm going to have the distance in the x's, or the change in the x's, so 4 minus 1, and then the change in the y's, and so this is going to give me 4 minus 1 is 3 squared is going to give me 9. Negative 1 minus 3 is going to give me negative 4. Squared is going to be 16. So this is all going to be the square root of 25, which is just 5. That's nice. So we know that's 5. And so now let's take the distance of CB. And like I said, it doesn't matter which way you set this up. If you do this is 0.1 or this is 0.1, it's not going to matter, because when you square everything, the distance becomes a positive number. So C, so we're going to have the change in the x's. So 1 minus 5, and the change in the y's. So 1 minus 5 is negative 4, but squared is a positive 16. 3 minus 6 is a negative 3, but squared is going to be 9. And sure enough, I have the same thing. Oops, I'm off the page here, sorry. So I have the same thing. I have 16 and 9. So this is still the square root of 25, which is just 5. So I have confirmed that these two sides are congruent. So we have the isosceles part done. Now we just need to show the slope of these two. So let's do the slope of AC, which is, of course, the change in y over the change in x, or x2 rather. So if I'm doing AC, I'm going to have the change in y, so the y would be negative 1 minus 3, and the x's are going to be 4 minus 1, so here I have a minus 4 over 3, I have a negative 4/3, and if I check the slope of CB, oops, sorry about that, if I check the slope of CB, I should get the negative reciprocal of this. So y2 minus y1 over x2 minus x1. Okay, so y2 is going to be 3, y1 is going to be 6, and x2 is going to be 1, and x2 is going to be 5. 3 minus 6 is negative 3. 1 minus 5 is negative 4. So this becomes a positive 3/4. And lo and behold, these numbers are negative reciprocals of each other. Okay, so we know that now these two are perpendicular, which shows me that those are perpendicular. And so the way that we would write all of this up in a proof, okay, so let's just think about how we would write this up in a proof. So our statements and our reasons. Okay, I'm not going to restate the givens just for the sake of time, because we know we were given the 3 points. But we could say that the distance of AC equals 5 by the distance formula, and we can say the distance of CB equals 5 by the distance formula. So we can say that AC, or rather, excuse me, whoopsie. Where's this? So we can say that since they're the same length, we can say that the distance of AC equals the distance of CB by transitive, and thus AC is congruent to CB by the definition of congruence. Okay? And then we can show that the m of AC is negative 4/3 and the m of CB equals positive 3/4 by the definition of slope. That's how we actually calculated that. And so then we can say that AC is, not congruent. AC is perpendicular to CB by the definition, or not the definition of perpendicular. Let's make this a little bit clearer. Because perp lines have neg-recip slopes. So then lastly we can say that triangle ABC is isosceles and right because of definition of isosceles and definition of right, and then you would be done there.